NFPA 101 Life Safety Code Section 7.9.3.1 requires continuous illumination of exit signs, exit paths, and areas where building occupants would assemble, for example, mustering areas or refuge areas. The NFPA codebook for future reference is NFPA 101 Life Safety Code. NFPA 70 National Electrical Code, or NEC, Section 700.12 requires that emergency lighting must be provided in certain locations, including exit paths and areas where the building occupants would assemble. Section 700.12 D2 states that emergency luminaires must produce light levels of at least 1 foot candle over the required area. Section 700.12 D3 prohibits the use of black light luminaires for emergency lighting purposes. The capacity of 100 people suggests that the building is considered a place of assembly. Specific requirements for places of assembly in NFPA 101 may apply. Firstly, stay up to date on fire safety codes and regulations by attending training or subscribing to relevant publications. Secondly, utilize online resources and forums to gather information and connect with professionals in the field. Thirdly, consider obtaining a subscription to a code interpretation service, which can provide expert guidance on specific code questions. A deeper dive into NFPA 101 and NFPA 70 is warranted to fully understand the night lighting requirements. NFPA 101, being the Life Safety Code, primarily focuses on ensuring the safety of building occupants during emergencies. The section concerning illumination is crucial because it directly impacts the ability of people to safely evacuate a building. Therefore, the requirements for continuous illumination are not merely suggestions but mandatory safety measures. Exit signs must be continuously lit to guide individuals towards the nearest exit. This is particularly important during power outages or other situations where normal lighting may be compromised. The exit paths, which include corridors, stairwells, and other routes leading to an exit, must also be adequately illuminated. This ensures that occupants can navigate these paths without stumbling or becoming disoriented. Areas where building occupants assemble, such as waiting areas, meeting rooms, or cafeterias, require continuous illumination to prevent panic and ensure orderly movement. Mustering areas, designated locations for assembling during emergencies, and refuge areas, protected spaces where occupants can wait for assistance, also fall under this requirement. Turning to NFPA 70, the National Electrical Code, it addresses the electrical aspects of emergency lighting. Section 700.12 mandates emergency lighting in specific locations, mirroring the concerns of NFPA 101. The exit paths and assembly areas mentioned earlier are again highlighted as critical areas requiring emergency lighting. However, the NEC delves into the technical specifications of this lighting. Section 700.12 D2 establishes the minimum light level required for emergency luminaires, specifying at least 1 foot candle over the required area. This is a measurable standard ensuring sufficient illumination for safe egress. The NEC also addresses what types of lighting are not acceptable for emergency use. Section 700.12 D3 explicitly prohibits the use of black light luminaires for emergency lighting purposes. Black lights, while having specific applications, do not provide the necessary visible light for safe evacuation. It is critical to understand why black lights are prohibited. Black lights emit ultraviolet light, which is not visible to the human eye. While black lights can cause certain materials to fluoresce, emitting a visible glow, this effect is not reliable for general illumination purposes. Moreover, the intensity of light produced by fluorescing materials under black light is typically very low, making it inadequate for emergency lighting. Emergency lighting needs to provide a clear, bright, and consistent source of illumination that allows occupants to see their surroundings and navigate safely. Traditional incandescent fluorescent, or LED lighting is far more suitable for this purpose. Considering the building's capacity of 100 people, it is categorized as a place of assembly. This classification triggers additional requirements under NFPA 101. Places of assembly are subject to more stringent regulations due to the increased risk associated with a large number of occupants. These regulations may include specific requirements for exit capacity, fire alarms, and emergency communication systems. It is important to consult NFPA 101 for the specific requirements applicable to places of assembly. Code compliance is not merely a matter of following regulations, it is about ensuring the safety and well-being of building occupants. Non-compliance can lead to serious consequences, including fines, legal liabilities, and, most importantly, potential loss of life. Engaging with qualified professionals is essential for achieving code compliance. A qualified electrician can ensure that the electrical systems, including emergency lighting, are installed and maintained in accordance with the NEC. A fire protection engineer can assess the overall fire safety of the building and ensure that all applicable codes and standards are met. Staying informed about fire safety codes and regulations is an ongoing process. Attending training courses and subscribing to relevant publications can help you stay up to date on the latest requirement. Online resources and forums can also be valuable sources of information and networking opportunities. Subscribing to a code interpretation service can provide expert guidance on specific code questions. These services typically have access to a team of experienced code professionals who can provide clarification and interpretation of complex code requirements. Emergency lighting systems typically consist of several key components. These include the emergency lighting luminaires, the power source, and the control system. The emergency lighting luminaires are the actual lights that provide illumination during a power outage. They must be designed to provide sufficient light levels and be properly located to illuminate exit paths and assembly areas. The power source for emergency lighting is typically a battery backup system or an emergency generator. The battery backup system provides power to the emergency lights for a specified period, usually 90 minutes, in the event of a power outage. An emergency generator can provide power for a longer duration, but it requires regular maintenance and testing. The control system for emergency lighting is responsible for automatically switching the emergency lights on when the normal power supply fails. It also monitors the status of the battery backup system or emergency generator and provides alerts if there are any problems. Emergency lighting systems require regular inspection and testing to ensure they are functioning properly. NFPA 101 and NFPA 70 provide detailed requirements for inspection, testing, and maintenance of emergency lighting systems. Regular inspections should include verifying that the emergency lights are properly illuminated, that the battery backup system is fully charged, and that the control system is functioning correctly. Testing should involve simulating a power outage to verify that the emergency lights come on automatically and provide sufficient illumination for the required duration. Maintenance should include replacing batteries as needed, cleaning the luminaires, and repairing any damaged components. Effective emergency lighting is not just about meeting code requirements, it is about creating a safe and secure environment for building occupants. A well-designed and properly maintained emergency lighting system can help prevent panic, reduce the risk of injuries, and facilitate a safe and orderly evacuation during an emergency. The NEC also provides specific guidance on the types of wiring methods that can be used for emergency circuits. These wiring methods are designed to provide a high level of reliability and protection against fire and other hazards. The NEC also addresses the issue of circuit separation. Emergency circuits must be physically separated from normal power circuits to prevent a fault in the normal power system from affecting the emergency lighting system. This separation can be achieved by using separate conduits or cable trays for emergency circuits. Emergency lighting is not a one-size-fits-all solution. The specific requirements for emergency lighting will vary depending on the type of building, the occupancy, and the applicable codes and standards. It is important to carefully consider all of these factors when designing and installing an emergency lighting system. The location of emergency lights is also a critical consideration. Emergency lights should be located in areas where they will be most effective in guiding occupants to safety. This includes exit paths, stairwells, and assembly areas. Emergency lights should also be located in areas where there is a high risk of accidents, such as areas with machinery or hazardous materials. The number of emergency lights required will depend on the size and configuration of the building. The goal is to provide sufficient illumination to allow occupants to safely evacuate the building. It is important to consider the potential for obstructions when determining the number and location of emergency lights. Obstructions such as furniture, equipment, or partitions can block the light from emergency lights and reduce their effectiveness. The height at which emergency lights are mounted is also a consideration. Emergency lights should be mounted high enough to provide adequate illumination, but not so high that they are difficult to see. The color of emergency lights is also regulated by code. Emergency lights must be white or a similar color that is easily visible. Red or other colored lights are typically not permitted for emergency lighting because they can be confusing and may not provide sufficient illumination. The use of reflective materials can also enhance the effectiveness of emergency lighting. Reflective materials can help to bounce light from emergency lights and illuminate a larger area. The selection of emergency lighting fixtures is also an important consideration. Emergency lighting fixtures should be durable, reliable, and energy efficient. They should also be designed to provide a wide distribution of light. The use of LED lighting for emergency lighting is becoming increasingly common. LED lighting is more energy efficient than traditional incandescent or fluorescent lighting, and it has a longer lifespan. LED lighting is also more resistant to vibration and impact, making it a good choice for emergency lighting applications. The integration of emergency lighting with other building systems, such as fire alarm systems and security systems, can also enhance the overall safety and security of the building. For example, the fire alarm system can be programmed to automatically activate the emergency lighting system in the event of a fire. The security system can be programmed to activate the emergency lighting system in the event of a security breach. Regular training for building occupants on the location and use of emergency lighting is also essential. Building occupants should be familiar with the location of exit paths and assembly areas, and they should know how to activate the emergency lighting system if necessary. Emergency lighting is an essential component of any comprehensive fire safety plan. By following the guidelines and requirements outlined in NFPA 101 and NFPA 70, you can help ensure the safety of building occupants during an emergency. Keeping detailed records of all inspections, tests, and maintenance performed in the emergency lighting system is crucial. These records can be used to demonstrate compliance with code requirements and to identify any potential problems with the system. The record should include the date of the inspection, test, or maintenance, the name of the person who performed the work, and a description of any findings or corrective actions taken. It is also important to keep records of any modifications or upgrades made to the emergency lighting system. These records should include the date of the modification or upgrade, a description of the work performed, and the name of the person who performed the work. The information provided in this narration is for general guidance only and should not be considered a substitute for professional advice. It is essential to consult with qualified professionals such as electricians and fire protection engineers to ensure compliance with all applicable codes and standards. Emergency lighting technology continues to evolve. New and improved products are constantly being developed, offering greater energy efficiency, improved performance, and enhanced features. Staying abreast of these technological advancements can help you make informed decisions about your emergency lighting system. Wireless emergency lighting systems are becoming increasingly popular. These systems offer several advantages, including ease of installation, reduced wiring costs, and increased flexibility. Wireless systems can also be integrated with other building systems, such as fire alarm systems and security systems. Self-testing emergency lighting systems are also becoming more common. These systems automatically test the emergency lights on a regular basis and provide alerts if there are any problems. Self-testing systems can help to reduce the time and effort required for manual testing. Emergency lighting systems can also be integrated with smart building technologies. Smart building technologies can be used to monitor the performance of the emergency lighting system, optimize energy consumption, and provide real-time alerts in the event of an emergency. The use of sensors and automation can further enhance the effectiveness of emergency lighting. Sensors can be used to detect occupancy and adjust the light levels accordingly. Automation can be used to automatically activate the emergency lighting system in response to specific events, such as a fire alarm or a power outage. Emergency lighting is not just about providing illumination, it is about creating a safe and secure environment for building occupants. By carefully considering all of the factors discussed in this narration, you can help ensure that your emergency lighting system is effective and reliable. Emergency lighting is a critical safety feature in any commercial building. It provides illumination during power outages and other emergencies, helping occupants to safely evacuate the building. NFPA 101, the Life Safety Code, and NFPA 70, the National Electrical Code, contain detailed requirements for emergency lighting systems. These requirements cover various aspects of emergency lighting, including the location, type, and performance of emergency lights. Understanding these requirements is essential for ensuring the safety of building occupants and complying with applicable codes and standards. One of the key requirements for emergency lighting is that it must provide sufficient illumination to allow occupants to safely evacuate the building. The NEC specifies minimum light levels for various areas, such as exit paths, stairwells, and assembly areas. The light levels must be maintained for a minimum of 90 minutes in the event of a power outage. Another important requirement is that emergency lights must be reliable and properly maintained. The NEC requires regular inspections and testing of emergency lighting systems to ensure that they are functioning properly. Batteries must be replaced as needed, and fixtures must be cleaned and repaired to maintain optimal performance. Emergency lighting systems must also be designed to be resistant to fire and other hazards. The NEC specifies the types of wiring methods and materials that can be used for emergency circuits. These requirements help to prevent a fire from damaging the emergency lighting system and compromising its ability to provide illumination. In addition to meeting the requirements of NFPA 101 and NFPA 70, it is also important to consider the specific needs of the building and its occupants when designing an emergency lighting system. Factors such as the size and layout of the building, the occupancy, and the potential hazards should be taken into account. The location of emergency lights should be carefully planned to ensure that they are easily visible and provide adequate illumination in all critical areas. Emergency lights should be located along exit paths, in stairwells, and in assembly areas. They should also be located in areas where there is a high risk of accidents, such as areas with machinery or hazardous materials. The type of emergency lights used should also be carefully selected. LED lights are becoming increasingly popular for emergency lighting because they are energy efficient, long-lasting, and provide a bright, even illumination. However, other types of lights, such as fluorescent lights, may also be suitable for certain applications. The control system for the emergency lighting system should be designed to automatically activate the emergency lights in the event of a power outage. The control system should also be designed to allow for manual activation of the emergency lights in case of a fire or other emergency. Regular training for building occupants on the location and use of emergency lighting is also essential. Building occupants should be familiar with the location of exit paths and assembly areas, and they should know how to activate the emergency lighting system if necessary. Emergency lighting is an essential component of any comprehensive fire safety plan. By following the guidelines and requirements outlined in NFPA 101 and NFPA 70, you can help ensure the safety of building occupants during an emergency. NFPA 101 and NFPA 70 are not the only codes and standards that may apply to emergency lighting systems. Other codes and standards, such as the International Building Code (IBC) and the Americans with Disabilities Act (ADA), may also have requirements for emergency lighting. It is important to consult with qualified professionals to ensure that the emergency lighting system complies with all applicable codes and standards. The design and installation of an emergency lighting system should be performed by qualified professionals who have experience in this area. A qualified electrician can ensure that the electrical systems including the emergency lighting system, are installed and maintained in accordance with the NEC. A fire protection engineer can assess the overall fire safety of the building and ensure that all applicable codes and standards are met. The cost of an emergency lighting system can vary depending on the size and complexity of the system. However, the cost of an emergency lighting system is typically a small fraction of the overall cost of a commercial building. The benefits of an emergency lighting system far outweigh the cost. An emergency lighting system can help to save lives and prevent injuries during a fire or other emergency. It can also help to protect property and minimize damage. Emergency lighting is an investment in the safety and security of the building and its occupants. It is an investment that is well worth making. To reiterate, black lights are not suitable for emergency lighting purposes because they do not provide sufficient visible light to allow occupants to safely evacuate the building. Black lights emit ultraviolet UV light, which is not visible to the human eye. While UV light can cause certain materials to fluoresce, emitting a visible glow, this effect is not reliable for general illumination purposes. The intensity of light produced by fluorescing materials under black light is typically very low, making it inadequate for emergency lighting. In addition, black lights can be harmful to the eyes and skin. Exposure to UV light can cause sunburn, cataracts, and other health problems. For these reasons, black lights are not permitted for use as emergency lights. Emergency lights must provide a clear, bright, and consistent source of illumination that allows occupants to see the surroundings and navigate safely. Traditional incandescent, fluorescent, or LED lighting is far more suitable for this purpose.